Welcome everyone, and thank you very much for joining our webinar on predictive fatigue risk management, from idea to reality and what's next. My name is Neil Clark. I've got the pleasure of doing the majority of the speaking today, and I'm joined with my colleague and customer, Colin Kerr. Colin, do you want to say a few words?
Yep, good afternoon everybody. Colin Kerr, retired Head of Projects and Safety from Edinburgh Trams, now currently providing the light rail industry some transport consultancy services.
Great stuff. Thanks, Colin. My name is Neil Clark. I run a company called IHF and IHF Digital, in which our predictive fatigue product BaselineNC sits. So today's agenda, we're going to define predictive fatigue risk management. What does it mean? Why should it be important to us? And what are we doing about it currently? And how do we look forward to addressing this fairly major organizational influencer properly? We're going to talk a little bit about BaselineNC, our workplace fatigue monitoring wearable solution, for which we've got quite a lot to say. We're quite excited about it. We're going to talk about how BaselineNC serves an enterprise-wide workplace fatigue risk management system, how we serve the users, how we serve the supervisors, and how we serve the enterprise. We're then going to talk a little bit about how this works in practice. How do we work with organizations? How do we work with partners? In particular, we're really pleased to speak about our AVEVA partnership and how we further enable the human sensor. We'll then welcome any questions. You can feed them into the chat and we'll pick them up at the end of the session. Predictive fatigue risk management, why is it so important? Why have we done what we've done? And where are we trying to take things? Well, for those of you who are involved in fatigue, whether it's at an individual level or an organizational level, you will be very aware of the traditional methods that we are relying on to measure fatigue. We're talking about surveys to measure sleepiness and fatigue. We talked about the HSE Fatigue Risk Index, monitoring sleep hygiene and shift patterns, and historical data rather than real-time data. I was chatting to somebody in preparation for this webinar, and they said that all the traditional ways of measuring fatigue are kind of like trying to drive a car, but using your rear view mirror. It gives you a perfect picture of what's happened in the past, but little to no evidence as to what's going to happen in the future. And I can relate to that. As my time as a military pilot, we used to fill out a form that said at the bottom of it on our out brief, are you fatigued and fit to fly? And are you fatigued and fit to fly was the last question, to which of course we always said no and yes. When we think about traditional methods, we think about invasive, self-assessed questionnaires and surveys, which can be fairly heavily manipulated by those that we're asking to complete them. They're also based on subjective analysis. So you're effectively asking yourself, how sleepy do I feel? And then from there, we take a self-assessed inference of fatigue from our self-perception of sleepiness. And there's just general inaccuracies in all of that, as well as some self-preservation. And looking at things like sleep hygiene and shift patterns, of course, all of these things are important, but they are rearward looking, and we can definitely do better than these in a multifaceted system. When we look at some of the technology that's out there, we are acutely aware of camera-worn and EEG devices, or measuring brainwaves effectively. And so whilst there is definitely merit in some of these systems, we found through experience and through talking to customers such as Colin and other organizations that there's quite a lot of sensitivity in and around camera-based systems. They are fairly invasive in terms of privacy. They measure and record much more background artifacts than just fatigue. Hence, they lead to the invasiveness side of things, because they're effectively monitoring your workplace. And they require a very static work environment in order to be effective, because you need the individual to be looking at the camera. The EEG devices, they can conflict with PPE, they can conflict with religious beliefs and practices. And if anybody's ever worn one of these things, it feels like your head's been trapped in a vice after about 30 seconds of putting it on. So all in all, there are other systems that are out there, but they have some fairly limiting factors. So why did we go into the activity tracking side of things? Well, we wanted to progress the fatigue detection on a couple of fronts. We wanted to up the ante on the unobtrusiveness of fatigue detection systems. So we wanted to provide a fatigue system that you kind of put on and forgot about. We also wanted to up the ante on being more proactive and more predictive. And so using our wrist-based wearable, it's a watch with a medical array on the back of it, we can up the ante on being unobtrusive. It really doesn't affect the vast majority of use cases or working places that we deploy it in. And it passively gathers information from the wearer and feeds it into a real-time monitoring system, which allows us to be incredibly accurate and incredibly proactive with predicting when fatigue, or more importantly, when inattention is going to fit in as a result of fatigue. So we've made some leaps, certainly from the traditional methods. We feel that there is merit in the camera and EEG devices, but we've tried to improve not just on the predictability, but the accuracy and the usability of our system, which is BaselineNC. I think it's always important that you hear from the people who use the device and can speak about it from a customer perspective. And Colin has kindly agreed to do that. Colin's going to talk about using BaselineNC in a workplace environment. Colin?
So in terms of BaselineNC, the reason why Edinburgh Tram went down this route was prior to 2016, the RSSB did a research project to try and identify if there was any technology out there. And basically they came back in their research and said that the technology wasn't mature enough. And then in 2016, there was a major tram accident in Sandilands Junction in Croydon, where the tram entered a sharp curve, which was signed to be no more than 20 kilometres an hour, but they were doing 73 kilometres an hour. And there was late application of brakes and absence of emergency braking suggested that the driver had lost awareness that he was approaching the tight left-hand curve. Although some doubt remains as to the reasons for the driver not applying sufficient braking, the Rail Accident Investigation Branch, or RAIB, concluded that the most likely cause was temporary loss of awareness of the driving task during a period of low workload, which possibly caused him to microsleep. In addition to that, in that location down in Croydon, the tram has to travel through a series of 3 tunnels, basically, and they believe the driver lost awareness, which is usually in the last tunnel before they come out of the tunnel. They apply the brakes so they can slow down sufficiently, but the driver lost awareness of which tunnel he was in. So the RAIB recommendation 4, as you see there, was that the UK Tram operators and owners and infrastructure managers should work together to research and evaluate systems capable of reliably detecting driver attention state and then initiate appropriate automatic responses. So the RAIB essentially wanted the industry to get something that would automatically apply the brakes, but that technology doesn't exist. So I decided then that I was going to try and explore this in a meeting with Edinburgh Trams and their client, City of Edinburgh Council. Their innovation manager was in attendance. We were discussing some other innovative ideas. And at the end of the meeting, the manager said, "Is there anything else we can do?" So we then discussed the possibility of having a system capable of monitoring the tram driver's state of fatigue and well-being. It would be a proactive system rather than reactive. It would be good if that were able to be worn by the user and relevant alarms provided. We further discussed the new work being carried out by NASA, would you believe? NASA engineers who had sought permission to reverse engineer a smartwatch to understand how it could be used for fatigue detection. We decided to follow up on the innovation project to have suppliers design a body-worn device that could provide a suitable warning. And so the Driver Innovation Safety Challenge was born in 2017, DISC for short. The tragedy underscored the need for proactive fatigue management system that can identify and mitigate risks before they led to accidents. Edinburgh Trams commenced the project in 2019 and conducted market research to find out if there was any existing wearable devices that could provide a solution. There were no wearable devices that could provide both fatigue and well-being. There were a number of things that could do fatigue, but they were again reactive rather than proactive. There was nothing that could be transferred into the transport world for well-being. So, as there were none, it's a solution monitoring various biometrics to preemptively identify the main typologies of illness, resulting in loss of focus, consciousness, or paralysis, risk of heart attacks, strokes, epilepsy, and identify the levels of the driver which could similarly create conditions of lost capacity. Solution to monitor and evaluate that information and make the tram control team aware in real time of the risk, enable the appropriate interventions to be taken through possible red, amber, or green alerts. Edinburgh Trams carried out market research to find out if there were any existing devices, and there were none. Edinburgh Trams and UK Tram carried out a tour of the UK light rail systems to appraise them of the intention, as with the recommendation from the RAIB, to liaise with the rest of the industry, appraise them of the intention to develop a solution in support of recommendation 4. All systems noted their intent to be kept abreast of the developments with the solution. So identifying the scope of the procurement strategy, however, was a challenge in itself, because normally when you go through a procurement challenge, you already know that there are the systems out there and you can set all your requirements based on what you know that these systems can provide you. Whereas in this case, you had a series of want to be requirements that somebody was going to have to invent a solution for. So IHF were chosen following the disc procurement exercise to deliver the wearable solution. So they were chosen out of 113 applicants. There's a lot of interest from all over the world on that one. At the time of the early design, COVID-19 was rampant. The early device used the known symptoms of COVID-19 so that the wrist-worn device could generate suitable biodata and could prove that the data could be safely gathered and fed into the machine learning process to generate appropriate algorithm. During the disc pilot, we had a number of medical experts in the fields of cardiology, cardiovascular health, medical systems, big data, computer modelling. Phase 1 of the project saw 20 volunteers wearing the device during their working shift, and the pilot confirmed the wearable gathered suitable data. So the evolution to Focus Plus. So through collaboration with the City of Edinburgh Council, Edinburgh Napier University, IHF, Scotland's Can-Do funding, Transport for Edinburgh UK Tram, Edinburgh Trams piloted the wearable fatigue management solution. The second phase of the project saw a name change to signify emerging from the DISC project with a pre-commercial device ready for independent testing. At this point, the Light Rail Safety and Standards Board, acting on behalf of the light rail industry, became engaged to support independent testing of the solution, so it's independently validated. Focus Plus wrist-worn device was tested by Edinburgh Trams and Ian Rowe Associates, or Avansum. Avansum is the main simulator manufacturer for all the light rail systems in the UK and widely in Europe and the rest of the world. They have a suitable facility to focus in on just doing the testing to make somebody fatigued while using the device. Edinburgh Trams carried out testing on the volunteers who had come off full driving shift and then continued to drive using our comprehensive simulator suite of tools. Our testing verified that drivers with significant fatigue and approaching the so-called microsleep stage, Focus Plus could raise an early alarm to enable the driver and the controllers to act in a timeous manner to avert a dangerous event, protecting both the driver and preventing unsafe acts. Early so-called red alert could provide significantly ahead of any unsafe activity, in some cases over an hour, thus enabling appropriate reactions to be rolled out. Avansum independently carried out similar tests at their offices in Milton Keynes and established that from a technical perspective, the system could reliably detect fatigue with a 98% reliability. That 98% reliability stacked up very, very well with all other reactive systems. This was the most reliable piece of kit from a technical perspective. So initial trials, and there's EIT Urban Mobility Project European funding. IHF Limited resolved all the outstanding bugs on the pilot device, and which you get bugs on every pilot device. And the current product, BaselineNC, underwent 2 further trials to establish its back office processes and to confirm IHF Limited ability to commercialise. The final trials were rolled out in Edinburgh Trams and in Hungary in Debrecen DKV. Edinburgh Trams carried out activities to develop acceptable use policies and assure the workforce that the devices would not be used to monitor their behaviours, only used to protect them and the public from dangerous events and unsafe decisions. What we did find was that when we got red alerts for the device, it was mostly down to drivers that were on a spare shift and inactive when not being used for driving. The spare shifts, basically, it's a driver that comes in to support peak time additional tram use or to assist whenever a driver of the tram has to get taken off for whatever reason, whether it's a comfort break or it's something else. They become unwell and they're coming off shift, so the spare drivers take over that shift. Essentially, what that meant was that the spare drivers have significantly long periods of inactivity, and then they're asked to go out and do something that requires high focus. And we found that these were the people who were coming up with red alerts, and we were able to deal with them. We changed the way the spare shift drivers spend their time at work as a result of that, and we were able to start making them do more competence management stuff by doing some training in the simulator suite just to keep them active, and that sort of resolved that. Following the successful completion of those trials, Edinburgh Tram became the first customer for the commercial solution. Other tram systems now becoming engaged with BaselineNC include Manchester Metrolink, Blackpool Transport Services, and Transport for London. Evolution to BaselineNC, the final name change for the commercial stage. The so-called humanisation that I spoke about in the previous slide was carried out by Edinburgh Tram to establish robust, acceptable use processes to implement the BaselineNC safely without introducing unacceptable changes to the risk profile of an operational tramway. Acceptability would be based around the alerts being used only to protect the users from making unsafe decisions that could cause harm to others. It should not be punitive. And so Edinburgh Tram took the decision that if a user had to be removed from work and sent home, then they would not suffer financially. The vast majority of those being sent home for fatigue, well-being episodes would present themselves for work the next day after a suitable rest. So not a huge cost to Edinburgh for maybe half a day's loss of shift. And not very many people. Edinburgh Trams did learn from that humanisation phase, and as I've said before, we did not get the perceived avalanche of red alerts from BaselineNC. There were quite few in occurrence. However, over the 6-month period, as I've said, the spare shift drivers became something that we needed to deal with. In terms of recent accidents and incidents across Europe, effectively, in fact, across the world, risks of working fatigue and rail have been highlighted again in recent accidents. The RAIB, that's the RAIB report number. You can get that off the website. Buffer stop collision at London Bridge Station, down to fatigue. Safety Investigation Authority Finland, investigation report, collision on tram line 15 in Espoo. So in Oslo, in Norway, recently there was a tram derailment in Oslo, where the tram derailed over a set of points, where those are not transport orientated. Points are a location where a tram can take a diverse route, and you'll have a certain speed to go through those to prevent you derailing or worse. So the tram in Oslo derailed over a set of points and ended up in the front of an adjacent Apple store, believe it or not. Although there were no injuries with this, it happened because the tram driver experienced severe stomach cramps, passed out and across the traction brake controller, accelerating over the points. And this was due to an episode of norovirus. San Francisco Muni Light Rail System in November 2025. The driver of the Muni Light Rail had fatigue incident and fell asleep. There's actually a good video of this on the internet, on YouTube. Fell asleep at the controls, and the light rail vehicle was recorded as speeding at 50 miles an hour. Luckily, the driver woke up by severe jolting as they passed over a set of points, and it knocked many of the passengers off their feet. Other than these minor effects, a more severe accident was averted by them waking up. A number of reported incidents in Australia relate to fatigue well-being include collision with Tram at Melbourne in 2017, derailment of a tram at Mooney Ponds, Victoria, March 2018, a waterfall rail accident, New South Wales, 2003, freight train collision near Perth, Port Hedland ore train collision in 2024. As you can see, they're not an insignificant incidents throughout the world for fatigue. All reports indicate the drivers probably experienced a fatigue and well-being episode, either heart attack, hypoglycemic drowsiness, poor fatigue management, or microsleep.
Thanks, Colin. That was really interesting. So we've heard from Colin how we developed BaselineNC, the various different stages it's gone through to the commercialisation. I think one point that I would like to pick up on is we have no doubt that BaselineNC works and does exactly what it says in the tin. Our model is to do a pilot engagement initially, and the reason for that is because there are some settling in. Colin referred to it as the humanisation phase. We often call that the operationalisation as well, because we're confident it works. It's just how do we make it really work for the organisation it's going into. We've had a question on the chat that I'll just address now as well. So the quick answer is yes. Lone working, heat stress are the two areas in which we have experience in using BaselineNC, and it isn't just limited to tram drivers. In fact, one of the things that I've been particularly impressed with in terms of the kind of product roadmap, if you like, is the fact that we've had interest from control room operators, we've got our pilots in the aviation sector. Some of the rail engagements that we've had don't just focus on drivers, they focus on maintainers and non-driving operators, if you like. So the opportunity to use Baseline in slightly different modes is really quite significant. In fact, Colin talked about the Debrecen DKV pilot that we ran. That was a European fund that supported us in that work, and the purposes of the European fund were twofold: to expand the product globally or geographically, and to expand the product modally. So we wanted to basically expand where we deploy BaselineNC and expand what it can do for its user populace. So thanks for the question. Happy to build on that if required.
Sorry, Neil, can I jump in there?
Of course.
It's very clear that it's, I mean, I've just been talking about trams industry really because that's where I worked. But reality is that the BaselineNC works for any lone working environment you care to mention, because not only were tram drivers on the Baseline pilot projects, but also the controllers in the control room and others. So it definitely can be used across all lone workers.
Thanks, Colin. One of the things that I was particularly keen on is that we, as Colin's talked about the spare driver, when we're going through proof of concept independent testing, you're dealing with marginal gains really, incredibly low likelihood, incredibly high consequences we've experienced with the Croydon Tram event and some of the other incidents that Colin has mentioned over the last 5 years or so. But one of the other added benefits of BaselineNC is how do we span that gap between nothing happening and something catastrophic happening? Well, the answer to that is there is a huge return of investment based on what I would call day-to-day operations. All of the figures that you'll see here, which I won't run through all of them, but they are all referenceable documents that you can find online. And we used a large organization, which is, so we could demonstrate the enterprise size of things. 500 users we've taken with an average gross salary of £40,000, an average working week of 46, and a Monday to Friday or thereabouts with 35 working hours. And so we know that there is a huge opportunity to return of investment from presenteeism, absenteeism, productivity, etc. So we've just ran some numbers here. So the potential number of fatigued employees across the organization, so 500 users, is 189.5. If you marry that against the productive hours lost to fatigue and induced presenteeism across the organization, so you're at work but you're not as functional as you could be due to fatigue, that comes in at around 36,000 hours. And then potential annual hours lost to fatigue-related absenteeism across the organisation is in and around 4,500. And so we can very clearly, in a step-by-step and evidentially backed, arrive at a huge number of in and around £3 million as a result of potential total annual financial costs related to fatigue in an organisation of 500 users. It is a huge return of investment. So the point that we're trying to make here is that a product that came out of the gates to ultimately prevent the low likelihood, high consequence events that no organisation ever wants to see, but there is a huge day-to-day benefit and return of investment from embracing a system such as BaselineNC. We were very selective in the biometrics that we wanted to lift. I must be clear, this is not a medical device, but we have got medical grade arrays on the back of that, such as the quality of the data. When we were dealing with the medical professionals that Colin mentioned earlier on in the presentation, what they were super excited about was that if you go into hospital and hook yourself up to a 16-lead ECG machine, you're going to get an incredibly accurate ECG reading, and that's fantastic. But you only get an ECG reading for the time that you're hooked up to the machine. So what we sacrifice in data quality, which is marginal, we make up for in spades in terms of data quantity, real-time broadcast live data that we can lift incredibly accurate trends off of. So we've got heart rate, we've got a 6-axis accelerometer, we've got skin temperature, we've got a partial ECG, we've got SpO2, and we've got galvanic spin response. We've selected these arrays because they give us the biggest combination of driving accuracy into our algorithm, and they give us the biggest opportunity to diversify. So lone working, we've got a GPS in there, we know exactly where people are, if they're in trouble, and if they're trending into trouble. I think that's the key point, predicting inattentiveness or trouble 30 to 90 to 120 minutes ahead of when an organisation needs to make an intervention. So we've selected really carefully our medical array to give us the best possible accuracy, to give us the best possible trends, and to give us the best possible diversification of use case. And all of these are supported by peer-reviewed papers. So we know that using a 3-axis accelerometer can help us predict fatigue to 62.4% accuracy. I've made that figure up. It's not too far from the mark, but there's a paper that publishes that accuracy of fatigue. We've got a 6-axis accelerometer, and we've got a number of other metrics that feed into our fatigue algorithm. So that's just one of the ways in which we predict fatigue. So how does this all come together? Well, we are building an individual baseline for the individual user, but we can scale that up at scale at an enterprise level. And we do that through two main areas. We can do it through a mobile application, which we've got for iOS or Android. So the device which I have here just directly connects to the individual's mobile phone, whether that's organizationally issued or personal issued, and we've had requests for both. Or we've got something which we call a hub. So in organizations where they have got a very sanitized workplace and they don't want to have any distractions through smart devices, then we can connect through our own IHF digital hub. It's really important that the individuals who are wearing these devices are provided with the information that they're gathering. So we've got a very intuitive app-based interface that tells them, you know, if we're connected, what the battery levels are. We can pre-program an emergency caller number in there. So if you were lone working, you can just hit the button, it'll go straight through to somebody who can help you. It'll take you on your fatigue journey. So going from normal through to elevated through to high risk, and it'll tell you the amount of time that you've spent in these various different segments. I see there's a question on data collection. So typically we speak to organizations, we say, we're only really interested in what we call boots on to boots off. We're only going to gather the data for the shift that the individual is working on for that organization. But when we engage with these individuals, when we're telling what we're doing, why we're doing it, and what we're doing with the data, we have got some really fantastic stories about people just, you know, ditching their smartwatch and using BaselineNC as their day-to-day watch because they're really interested in the information that it provides through the app. And so what we were anticipating is industrial relations, union issues actually transpired into more usage of the device. And we can add just extra dimensions to our data layers by starting shift, stopping shift, etc., etc. The other thing that we want to make sure is that we've got a safe driver mode. So we understand that organizations will issue a smartphone, but they don't want, you know, the worst case scenario for us, of course, is that there's an incident triggered by distraction, by fiddling around with the app that's designed to prevent that very thing. So we've got safe driver mode, which allows us just to effectively put the app on silent and remove any chance of distraction. It gives us historical data. It also tells us how we're doing in terms of training because we've got a generic baseline that we can deploy onto anyone. We typically spend about 2 weeks training that algorithm, which is reflected here, which you can see, hello Alex, your training period tracker is 50%. So you've got a little bit more to gather before your algorithm is specified to yourself. What's really nice is that if the system at the end of that training period thinks, I've not got enough of Alex's data here, it will then inform us that we need to extend that training period. So we would never have anybody in an operational phase of using the app with an incomplete or untrained data set. And I think that's really important, not just for maintaining our 98% accuracy claims, but just to ensure that the system is actually on and tuned as it goes into operational use for that individual. So that's us at the user level. It's very unobtrusive. They put it on as a watch and then they forget about it. It tells the time, it shows the date, it gives us step counts because that's everything that we've been asked for from our user demographic and our testers. All of this information can be fed up into the enterprise. So we can see how many active drivers we've got, how many active alerts we've got, who are the people that we need to focus on, where are those individuals on the map, all of these things you'd expect to have as a supervisor. And if you were to go to Edinburgh Trams, they've got a dedicated dashboard that allows the tram supervisors or the control room operator to see where all the tram drivers are and what status they're in. It's incredibly powerful and very good to understand that, you know, the data that falls out of this from a planning and prediction perspective, we can understand who the most fatigued individuals are, where the fatigue issues happen on certain shifts. Is it certain routes? Is it certain parts of the year? All of these things help us inform what I would call traditional fatigue measures, shift design, overtime management, spare shifts that Colin mentioned earlier on. All of these sorts of things can now be data informed rather than just being taken from subjective measures. So really powerful control room dashboards that can be assigned to specific control rooms, specific individuals, so that we know that we're genuinely extending that duty of care. And of course, if we are worried about the control room operators falling asleep, we can put a baseline device on them as well. So we've got all the bases covered. So this is just rolling all of this up into analytics dashboards. So we've talked about the users, we've talked about the supervisors. Now we're talking about, well, how much business intelligence does this system give us? Well, the answer is an enormous amount. We've got some engagements, the organisations that Colin mentioned before, they are, of course, interested in real-time operational fatigue issues or fatigue events and how do they manage them and how do they keep the operation safe. But they're actually more interested in how do we use this data to properly design shifts and properly design the organisation. What have we got in terms of minimum manning? What have we got in terms of maximum manning? How much redundancy do we need in the system? And some of those discussions, one of the seminal lines that came out from that was when they're trying to design fatigue shifts, somebody said to me, Neil, the thing is we can design a shift that is fatigue resistant as we can possibly make it. But the problem with that is it doesn't align with our social norms. It doesn't align with picking the kids up from school. It doesn't align with having a social life, etc., etc. So using this system, yes, to predict and prevent operational fatigue events, but also for making sure that we're using the data to plan the organisation appropriately. That doesn't just extend to railways and tramways, but also from oil and gas organisations who are looking to reshape their employee base to make sure that they've got better coverage of oil wells on land-based sites, etc. So the data that falls out of this is absolutely phenomenal. So this is one of my favourite slides. So the reason that we've got this humanisation or operationalisation phase is that there's a general tendency and general anxiousness that if organisations feel that if they put this system onto the individual, then automatically they're going to have a whole load of fatigue events and the organisation is not going to be able to manage it. That's just not the case. We haven't seen any evidence of that. In fact, this is some data from one of our long-standing clients. And what it shows is with a better understanding of fatigue, a better understanding of fatigue events, the organisation experiences less of them. And that's really, really powerful. With better understanding becomes better awareness, comes better management, and ultimately less fatigue events. And that's really what we want to see. We don't want to see an organisation with lots of fatigue events that we're catching and can be managed, although the system can do that. We want to see the system generating the business intelligence that we can actively manage the system issues or the fatigue issues in a downward trajectory. And that's exactly what this says. You'll see there's some gaps in the usage. That's because it's pilots and we only had a select few individuals on the pilot program, and so they were on periods off, etc. So that's what we're doing here. That's what this graph shows. It's probably one of the most powerful slides in the deck. One of the other things we're talking about, further enabling the human sensor, so allowing for a predictive maintenance approach that is often utilised in asset performance management. So we do a lot of work in oil and gas, we do a lot of work in highly technical sectors, And for the last 10 years, they've been talking about how do we predictively maintain the pump? How do we predictively maintain that technical asset? And they've done that. You know, they can measure vibration, they can measure heat stress, they can measure output, they can measure a whole load of things associated with technical equipment, but they don't do the same for the most valuable yet most vulnerable part of the entire system, us, the people. So using BaselineNC to drive the same level of analytics you'd expect to see in a pump, a compressor, something else critical to the organization into the people is incredibly valuable. It means you can get ahead of presenteeism. It means you can get ahead of absenteeism. It means you can properly design shifts. You can properly articulate your breaks and your rest periods, ultimately with an aim of improving the bottom line, improving performance, efficiency, and productivity. Yes, this is a safety-born device, but the benefits of it are far, far reaching. When we talk about human factors, we talk about just and fair culture and balancing the accountability between the individual and the organisation. Well, the organisations play a massive part of putting the individuals in place or not, which makes them susceptible to fatigue. So reaching back to some of the analytics and data that we've showed earlier on the slides, how do we get predictive analytics through real-time monitoring that are used to mitigate the influencing factor that is fatigue? And the answer to that is we can do that just by gathering the data that we use to affect real-time operational fatigue detection. Really, really powerful. One of the partnerships that we wanted to talk about was the AVEVA partnership. So AVEVA, there's independent software vendor, industrial hardware manufacturers, and there's managed solutions providers. There are different channels to the AVEVA partnership. And we have registered IHF Digital as one of the partners to fill that array. You know, we've got organizations who are gathering data hand over fist from their organization. We were speaking to an airport recently, and they had 47,000 data points that came out of the airport. Not one of them related to the people that operated in that infrastructure, that airport. So, you know, we're really trying to plug that gap, that in order to have this complete data set of the organization, of the collective asset infrastructure, you need to be measuring the person, the human sensor. And there are ways and means of doing that. We can deal directly with the organization, but one of the sweetest ways of doing that is working with an organization such as AVEVA, who's already gathering all of those other data streams and feeding into that to make it a really rich and human considerate data set. The other thing which is mentioned here, and I see there's a question of in the chat, that we are very careful with the data management. So we have got an anonymized data that sits in the cloud. Of course, at some point, we need to be able to identify that it is David driving the tram and that David needs some support. But at no point does our biometric data sit within identifiable data in the cloud. On top of that, we've got all of the tier one infrastructure that you expect to see. All of these things are super important to maintain the accuracy and the confidentiality of the data in the system. Thanks for sticking with us. Straightforward pilot testing. How do we engage? Well, as I said before, we know that the system works. There is no doubt in my mind. The question is, how do we make it work for the organisation that's interested in it? Well, the quick answer to that is we do a 90-day pilot. Why do we do it over 90 days? Well, it gives us that sweet time to not overextend it. It gives us an opportunity to demonstrate value really quickly whilst accommodating that training period. And it also allows us to work with the client to say, right, here's the data that's coming through. You've got those trained individuals. This is what we're seeing. How can we use that in terms of preventing operational fatigue detection events? How can we use this information to feed into the planning and the organizational elements? And how do we learn the lessons that allow us to expand that pilot across the enterprise? And that just kind of sweeps up all those points. Will involve collecting longitudinal objective data from workers during operational scenarios. As you can see here, here's one of our Hungarian drivers. We do that all very succinctly. So we deploy the devices. We've got this general algorithm that I talked about before. We induct these individuals. We show them how to wear it. We show them how to look after it. We show them how to charge it, how to connect to the hub or the app. The vast majority of people are using the app now. We show them how we can tell them that we're being trained through this, you know, how their training of their algorithms going and where to get the information from that, from their app. And then we talk about what we're going to do with the data, how it feeds up into the enterprise, how it feeds up into their supervisors, and what they can expect. During that period, it gives us a really good opportunity to demonstrate the authenticity and sincerity of what we're trying to do. There's no big brothers watching. We're doing this because it's the right thing to do for organizations to keep them safe and to keep the people under their duty of care safe as well. So we spent a long time thinking about how to end this presentation. So thank you so much for sticking with us. I'll finish up on this slide and then I'll jump into some of the questions. We know that fatigue's an issue. When we go and speak to clients, we never have to explain the fact that fatigue's an issue. The organisations that we speak to, and probably organisations that are on this call, understand that fatigue is an issue and it can kill. We think it is the biggest performance influencing factor in enterprise organisations. We also know that there are some traditional ways of measuring fatigue. But we also know that there are some serious shortcomings in that. Our challenge, I suppose, is that we now know, because we developed it, there's a better way of tackling fatigue. And so is it time to take a break and reconsider how we go about delivering value into the organisation by a data-driven, unobtrusive, wearable approach to fatigue management? Thank you so much for your time. I'll just jump into the questions. And so the first one is, are there any ethical issues connected with the privacy of the collected data, how the data obtained with BaselineNC are protected? Is this product or the fatigue management system meant to be compulsory? Yeah, so in reverse order, is it meant to be compulsory? That's an organisational issue. We've got organisations who come at us from different perspectives. They've had an incident, they've nearly had an incident, or they're struggling with designing the organisation to accommodate their workers, their users, their operators. We've never dealt with an organisation who said you must do that, or do this, or wear this. I don't hope that that day comes. I am far more of a carrot than a stick kind of guy. So I would want to see individuals and organizations see that this is a real value add with very little to no downside. So we want people to embrace this because they know it's the right thing to do and they want to get on board rather than just being hit by the stick. Ethical issues. So in the UK, we're dealing with what we call special category data. And special category data has a whole lot of requirements around about how you collect it, how you process it, what you do with it, what the outputs are, ownership of that data, etc. And so you would expect us, and we do, to have every single one of those boxes ticked. We anonymize the data in transit. We've got it incredibly tightly managed. As I said before, we never collocate biometric data with identifiable data, so that if our system was compromised, I could never say, oh, there's Colin Kerr, there's something interested about his biometric data. That simply wouldn't happen. I think all of this comes down to the engagement piece. And I mentioned authenticity and sincerity earlier on. It's super duper important that we've got the hearts and minds of the people that we're asking to wear this. Unfortunately, the unintended consequences of fatigue events, people dying, people being hurt, systems and environments being damaged, they have happened time and time again. So unfortunately, we know those unintended consequences can and do happen and have done over the last 12 months. And so we are there to add value and safety to organizations. So I hope that answers the ethical issues. How are you measuring or capturing fatigue in the workplace? That's really what the system does. That's what the algorithm is designed to do. I mentioned before that there are traditional methods of measuring fatigue are sleep-induced or sleep-inferred fatigue. So you infer fatigue through sleepiness. The only way of identifying fatigue is through what we call a documentable decrement in performance. So how many errors, how less productive do you get in completing a task as fatigue sets in? And we've done all of those studies. We've had Stroop tests, we use a Karolinska sleepiness scale, we've used vigilant motor tests. So we've done all of that work, and that's what our algorithm's based on. And we also, through the app, continually gather that data. So we've got opportunities to continually label our data, because ultimately it goes into a machine learning system. So we've got our generic model, which is accurate to begin with. Then we've got our specific model. That specific model, once trained, just gets better and better and better. Insurance companies willing to reduce their premium. We are working on it. That is the sweet spot. We've already engaged with a loss adjuster who's helping us craft that very solution. So if an insurance policy costs £100,000 a year, I'm making figures up, a baseline costs £50,000 a year, for example, if we can get that insurance company to drop their premium to £900,000 a year, £50,000 comes to us for the implementation of the system, and the insurance company reduces the risk of payout because we're actively managing fatigue, which was one of the main organisational contributors to incidents and accidents. Everybody wins.
When we implemented what we call RM3 in Edinburgh Trams, one of our safety guys went to talk to the insurance about it, and he got a reduction in the insurance premiums based on the improvement in safety. And so taking that argument and moving it across to BaselineNC, there has to be a case for getting reduced insurance premiums.
Thank you, Colin. There you go. Answered that better than I did. Thank you so much for your questions. Thank you so much for your time and attendance. Just before we go, we've got some upcoming webinars. We've got one on human factors integration, UI and UX, designed for digital systems, particularly with the advent of AI and all of that coming our way. On the 24th of June, we've got an introduction to incident investigation and our incident investigation software, HFAir. And then on the 6th of August, we've got an end-to-end walkthrough of the safety critical task analysis process. Thank you again for your time, and we hopefully see you again at some of these events. Lastly, we've got our new system, HF, which is an online HF maturity assessment tool that allows you to get a really good understanding of where you are on the HF maturity curve, what's going well, what could do with improvement, maybe what you should be doing a little bit more of. Very specific to your organization. So check it out if you get the opportunity. Thank you very much.